Hello and welcome back to Networks and Cybersecurity. Today we're going to briefly go over what you had to do for the exam, and then we'll go into some NMAP stuff we didn't look at last time, and then if we've got some time, since it's the day before the general election, we're going to just look at some cool general election stuff. Alright. Okay, so let's start with how to complete the exam. Start with how to complete the exam. First, I gotta post this link over to Discord. I forgot to do that. And now we'll lay into the exam in a minute here. I'm gonna give everybody else a chance to get on. I know a lot of people joined via the Discord, so give everybody a moment there. Am I audible? Let's see. I think I am. Check it out. Yep. Helps if I have my feedback on. Okay. Alright, so exam review. Checking out how to do this. So it was a lot of mystery on this exam, but most people figured it out really well, really quickly. This was an exam primarily based on NMAP. You had to go into Eclipse maybe a little bit, depending on how you did it, but the intent was actually, again, like the first exam, to make the whole thing completable entirely through Wireshark. And that is why the integer goes last here, actually. We'll see why that hint was important in a second. So, let's go ahead and see if I can start the server up. Now, I'm going to get a little bit of different results on my end because I'm running it locally. So one of the things that doesn't work on localhost is the SYN scan, so that -SS option, which is the one that almost everybody used. And that doesn't work on loopback. Doesn't particularly matter why, but it doesn't work on loopback. But the connect scan does work because that establishes a full socket, and you can actually make full TCP sockets on loopback. So that option is going to work for me here. All right, so the first question, it was to discover the server. So I had a couple distractor servers running on TCP and UDP. Most people realized that it wasn't going to be on UDP. And that was a practical concern, right? Because UDP scanning takes a lot longer to do. You saw before that to scan 1,000 UDP ports would have taken you, 10, 15 minutes alone. So you probably could have guessed that I wasn't going to use UDP just based on the shortness of the exam. But I did have a couple of distractor UDP servers running. They weren't very interesting. They were basically just those echo servers that we did that echo back the string to you. And there were a couple things running on TCP. There was one server that just counted and it sent a bunch of numbers, basically. And there was another one that's the one that you were actually looking for. And it sends these 3 pieces of information on loop every 3 seconds. Now, what you were supposed to observe in Wireshark to figure out which was which, right, was that the one that counts every 3 seconds has traffic every 3 seconds in Wireshark. So that was all the purpose of that hint and the purpose of structuring it that way. See, both servers, the distractor and the real one, sent serialized information. And so some people did get a little bit tripped up by that and ended up picking the distractor. The real one is actually this 67521. The 68641 that you might have discovered was the distractor service. And again, you could tell them apart primarily by the fact that the real one sent its data in 3-second increments. So I'm going to try first a regular scan, a -SS scan on my address, and we're going to see that it's going to find nothing. So I'm going to put the port as 6,000 to 7,000. Try not to make a mistake there and leave that as 600. We're going to try that out, and we're going to see that I find probably nothing, because again, it doesn't work on loopback. Well, let's go back to our other available resources here. We have our different malformed packet scans, and then we have our UDP scan, we have our ping scan, and we have this connect scan, this -st. So let's try that out instead. And again, you wouldn't have had to do this. It probably would have worked for you. I'm actually going to narrow down the ports just for demonstration purposes here. I'm going to just set it to, let's say, 6,750 up through 6,870. So this covers pretty much exactly the range where I've actually hosted my service, so that should make it run a little bit faster. There were a lot of defects, by the way, with both of these services, so they ran into a lot of exceptions. If you really want me to, I will upload the exam source code, but it is terrible. I just want to remind everybody, please don't use it for any of your actual homework. It's just some stuff I cobbled together as fast as I could. It really is not good in any way. Don't use it for anything. Okay, so we see nothing from this scan again, just because of that local loopback issue. And this should be something that you should remember for if you're trying to use NMAP. If you're just trying to test it out and you're using it on loopback on yourself, it's not going to work. So just remember, connect scanning might, but this will not. So we see some exceptions start to come up as those sockets are made and destroyed, and my crappy not exception handling source code doesn't deal with them correctly. Let's open up Wireshark and see if we can. Is this the right machine's Wireshark? I don't think so. I think that's mine again. Hold on, am I in the VM? Yes, I am. Okay, we're good. It's always hard to tell. All right. I'm going to use the loopback adapter to try to catch this stuff. And let's see if I'm getting anything. Now that I've identified the port that's open, I can start looking for traffic on it. So TCP.port, let's look at 6752, that first one. Okay, we see no traffic right now because the next step was to use one of your existing examples to actually establish a connection to the server. So you couldn't just use NMAP, you actually had to establish a connection using one of your different TCP applications. Now, another option, if you were connect scanning, I'm going to just specify that port specifically to make this faster. If you're connect scanning, remember that it actually does establish a connection. However, you're going to get a reset pretty much as soon as possible. Now, you are going to get one payload out of this occasionally. So one option was, instead of actually running one of our different client applications to try to get the NMAP connect to send you the message in that final acknowledgement or just before the connection gets reset, that probably wasn't possible. But if you moved fast or tried it enough times, it might have been. But let's go ahead and run one of the many other networked examples that we have. So let's see, I got homework 4 here. Here's something that looks like it's a client. Sure. Change that IP. And what was the port that we were looking for? It's 6752. Whoops. Oh, jeez. 6752. Sorry, not my day for typing. And now we just have to wait for the CSVM to save. And we can move along. So this actually establishes a real connection. And now we're going to see that it sends something back every 3 seconds. Now, how do we know that it's every 3 seconds? Because we look at the timestamps in Wireshark. We see that it sent a series of traffic at 124, then a series of traffic at 127, then a series of traffic at 131, then a series of traffic at 134. That's every 3 seconds. If you were to look at the other service that was running, it was sending stuff continuously. So that's how you were supposed to differentiate the two. Now, this was an interesting quirk because in some cases when I ran this, it sent every serialized object in individual segments. And in some cases when I ran this, it sent every serialized object in a single segment. So some of you might have gotten actually both of those. I think almost everybody got it in a single segment. Let's see what this one looks like. It actually doesn't change anything in particular, But it's probably due to something called Nagel's algorithm, which we're going to look at a bit later, which is something that can plague application developers as well. So something to consider is that you never know whether your data is going to come in multiple different segments or one. Remember, this stuff is totally abstracted away from you as a developer. All you see on the receiving end is a stream of bytes coming in and a stream of bytes going out. So you don't know how it's going to break it up on the TCP level. So in this version, it looks like I got them in individual segments. This one's actually a little bit easier to read when they're all in individual segments like this. So the answer to the first question, the port was 6752, and it was a TCP port. And I misspelled TCP and called it TDP, but you get the idea. It's TCP port 6752. Most people got that portion. All right, now you have to decode the serialized string that it was sending. This part was supposed to be a gimme, but some people didn't get this because they didn't observe the Wireshark payload, or perhaps they thought that it wouldn't be in there. But it actually is just directly, because I sent it as simple UTF-8. You can just read it right out of the Wireshark input. If you had it in the one packet version, as most of you had, there was this after it that some people thought was part of it. But no, it wasn't. It was just a hello, moon, and stars bit. So you would have had to make a little bit of a guess as far as where it starts and ends. But since these are the only complete words that you see in there, it would have been a pretty reasonable guess to see that the message was hello, moon, and stars. Now, the only way to actually get for sure the answer to all three of the contents in there is to do something in your code to create a object input stream and then to receive these three objects and actually print them out to the console. That would have been the full-fledged solution. But just looking at the Wireshark, you could have made a pretty good guess without having to do that. So that's probably what I would have gone with hello, moon, and stars here. And if you did include any of the extra portions, the URs or whatever, I only took off like 5 points for that. Alright, so next you were supposed to find the character array that was being sent. Now this was a little bit harder because if you try to just decrypt the object input stream as a character array, it's a little bit more difficult than getting a string or an int. You can't just print it to console and get the answer. So this one was a little bit harder to do if you were doing it the program way. So what I would have recommended that you do if you did it the program way here was just print the length of the character array and then observe in Wireshark what you can find that is that length. So the only other kind of full-fledged string that comes in here is the word Venus here. And you'll notice it has these little separators between them as well. Right, so this should be pretty indicative to you that it's some kind of structure that's not a string. So the string came in obviously all in one piece, aside from different spacing due to the way that Wireshark displays it. It basically comes in all as one chunk, whereas the character array you can see comes in with spaces in between, or not spaces necessarily, but other characters in between it. You also see some of that serialization overhead, that UR, C, and F here. This obviously indicating that it's a character array. We see the little square brackets and everything. What comes in before the string comes in? Well, we get this kind of strange message here. This doesn't really mean anything to us, and then we get sort of some more strange messages that don't mean anything to us. Oh, sorry, I'm looking at the wrong end. We get some strange messages that don't mean anything to us. We get this Y, and that's it. And then we get the string right after. So the string has a lot less overhead for serialization, it looks like, than a character array. Anyway, so you see that the only thing in there that's basically a word other than the string is this word Venus. And you could have extrapolated from there that that's going to be the answer. But again, if you really wanted to confirm it, then you would have probably had to get the object, actually receive the object in your code, which I'm not going to go over. And in that case, you could have figured out how to print it, or my recommendation would have been just to print out the length of it and then find something of that length in Wireshark. If you know that it's length 5, then it's pretty obvious that Venus is the right answer there. Alright, so continuing on to the integer, this was the hardest part for most of the folks who did the Wireshark only solution. So where is that guy at? Oops, I'm into the 38s already. Okay, so it begins with java.lang.number, so we know that this is going to be the integer package coming in here. And then there's some more overhead and some more overhead. And I gave you this hint, right, that the last 4 bytes of the payload would be the integer, right, because it was the last thing that was transmitted. So let's go back to the thing. It says the last 4 bytes of a serialized integer in Java are the actual int value, and the rest is overhead for serialization. You'll remember I sent an integer on exam 1 as well, and a lot of people had trouble with it, so this is kind of a callback to that. Recall that the integer is the last thing in the transmission here, so it's literally, because it's the payload follows the header and everything, it's going to literally be the last 4 bytes of the transmission. So let's look at the last 4 bytes of the transmission. At 134 here is the very last segment that comes in. This is the acknowledgement, so that's not the one I want. I want the one that comes from the server. And it's got its last 4 bytes right here. It's a 4 byte payload. And in your case, again, if it came in as one segment, it would have been the very last 4 bytes of that one segment. And it's 000000F. What is F in base 10? It's 15, right? 0 through 9, and then A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So 000000, F is 15. Which means that you're starting to replace from spot 15. Spot 15 happens to be the S in stars, which means that the full message is Hello Moon and Venus. Okay, that's it for how I would have done the exam. Again, the more reliable solution would have been to do it in programming the object input stream. I would have just taken the example that we already had in class, that object input stream that we used for the homework solution, and I would have just repurposed that to basically receive the objects from the server instead. So you would have just changed the IP and port, and then just left in all the other stuff that has to do with color grid because it doesn't matter, and just change the code on the receiver a little bit, and that would have done the trick for you. Alright, if there's any questions, let me know. I'll hold off on holding this for now, on closing this for now. Now let's get into what we didn't finish about NMAP. So we got up to, I think we got up to here really, and then I didn't quite cover the next slide. So how to specify the port ranges. And then we were talking about how some servers reject pings, and NMAP by default will attempt to ping a host before it starts the scan, so before it starts to send the TCP or the UDP traffic that it sends. First it tries to make sure that the host is online, which means it'll send them an ICMP echo request. If they don't respond, then it doesn't go forward with the scan. So if you want to instead go forward with the scan regardless, you can use this -pn option. That skips the discovery phase completely, so it doesn't send that ping. Or if you want to try to discover that machine using an IP datagram, so remember one layer down, we're just going to send them an IP datagram and see if they respond. Or if we get an ICMP unreachable message, then we use this P0 option instead. So sometimes these will discover machines that are configured not to respond to pings exclusively. So they're just configured not to respond to pings, but they will still respond to datagrams. It's pretty rare, but it's occasionally something you'll see from computers that have been overloaded by too many people pinging them. They'll just disable pings specifically. So some other options that you can add to your NMAP scan. You can detect the operating system on the receiving end using -O. That'll try to figure out what operating system they're running on by using a collection of information about different operating systems that NMAP has built up from basically volunteer contributors over the years. So one way that you might be able to identify the operating system, for example, is on certain Windows systems, when you first communicated to them, they would set the window to a specific value, like 65,000 exactly or something. And this was just a feature that the operating system designer built in. But this also gives away what system they're running, because only that specific system responds that way. Sometimes operating systems are given away by more subtle things than simple settings like that. Sometimes it's something like Nagel's algorithm, which we'll go over later. Sometimes it's something like the timing in which they send their TCP messages. Maybe they send them a specific length apart. The amount that they're willing to delay the transmission of different TCP messages. All of these things can give away what operating system your host is running. So if you'd like, I have my machine up and running now. You can feel free to ZenMap me and try to see what machine I'm running, what operating system I'm running on my machine. I am, again, 143.105.165.12. So go ahead and give that a shot. I'm going to go ahead and try it on myself here, and we'll see what it says. So I'm going to use this -O option. That might be too broad of a scan. Let's say I'm going to go back to just a ping scan. I'm going to try just a ping scan instead of scanning everything. So how do you do just a ping scan again? Well, let's go back a bit. That's going to be right here. So just a ping scan SP. This isn't going to look at any ports. It's just going to look at whether or not the machine is online or not. So let's try that and see if I can get operating system detection. Darn, unreliable without port scanning, right? So you need some information from the ports in order to get a proper operating system detection running. So I'm going to use operating system detection with -SS, and I'm going to specify just those early ports, so those 0 through 1024 ports. Hopefully that's enough in order to get a fingerprint. Let's see. Well, that'll likely take a second, so we'll come back to it. All right, other options that you have. You have your service scan. Remember we talked about once you've identified which ports are open, you obviously want to see what services are running on those. So a service scan will tell you whether the server in question is running something like a web host or FTP or whatever. Again, these are built using fingerprints collected by volunteers. HTTP sends its traffic obviously in very particular ways. If you're getting HTTP traffic, then you know that that's a web server. Likewise, FTP sends traffic in very specific ways. But then there are also thousands of other applications out there, right? And every time you interact with that kind of application, you can collect that data in like your PCAP Wireshark files and upload them to the NMAP project, and they can use that information in order to fingerprint other people who see the same kind of traffic in their trace. Let's see if it was able to guess correctly. Still going. Okay. You can also use this -T option and then specify numbers 0 through 4. So don't use an X, you're putting a number 0 through 4 there. And that changes how aggressive NMAP is, which is basically how often it sends traffic. Remember, the more often you send traffic, the more likely you are to be detected or caught. So you want to be as not spammy as possible, but if you don't care about being caught, you can just set that thing to 4 and call it a day. Let me see what somebody got on their -O scan of me. They got Microsoft Windows 10, which is correct. That is what the VMs are running, right? So it was able to identify which version of Microsoft Windows 10 we have as well. It got Microsoft Windows 10 1709 through 1909. We'll see if that's true. I don't know. Probably is, though. Actually, we'll just take their word for it, that it is one of those operating system versions. And it also found a bunch of other open ports in the reserved range, and it was able to identify their service name. Let's see if mine finished so I can show you guys the same thing. Now mine will likely have failed, right, because I did -SS on loopback. Oh, whoops, I forgot the dash in my O. I don't know what this thing was scanning. But anyway, look at the one in Discord instead, because that one's going to get actual results. Mine, again, is probably going to fail because I'm on the loopback. But see, I've got 3 services running there. I've got MSRPC, NetBIOS, and Microsoft DS there, right? And those are all things that the university probably has running on the CSVMs for various reasons. Those are all common services that are known by NMAP, basically. So it was able to identify them just based on the kind of traffic that they send. We're not going to go into any of those, but NetBIOS, if you've done any IT, is like an administration tool for Microsoft systems, so it's probably how they administer their VMs, which means that that is a potential attack vector. If you were trying to get into the VMs there and do something nasty, you'd probably go through NetBIOS as one of your options if you could crack in there. Other options that you can add, continued, you can add -A, which is an aggressive scan, which basically just has no care about whether or not you get detected or not. It sends the traffic as fast as it feels like it. It does all the different scans available on every possible port, and it'll do operating system and service detection. If you don't care about getting your IP blocked, you can do it, but it will come up as a DDoS by most machines, so you probably don't want to do it on the university's network because you don't want to get your machine blocked on the university's network. If you want to play with it at home on your own machines, by all means. This is also a reasonable way to DDoS a machine, is to run a bunch of -A scans on them. This is about as much traffic as you can send to a bunch of different ports as possible. It's not a great DDoS, but it's a reasonable one in the sense that it sends a bunch of traffic. A list scan is used as a way to identify all the IP addresses in a range. So instead of identifying a range of ports, you give them a range of IP addresses, and then it'll basically do a ping scan on all of those. So you can see, again, all of the machines that are online in the network, that enumeration process that we talked about earlier. Now, remember that when you use NMAP, the results that you get are not 100% accurate. Usually you will need to scan a couple times to confirm that your results are good. The further away you are from the server, so when we're on the university network, we're all local to each other, we have no latency, we're one hop apart. But when you're far apart, and there's a lot of hops between you, that can really degrade results. First, you could be blocked by servers that are partway through, so maybe one of the routers along the way doesn't accept ICMP traffic and drops your traffic. That's not good because then it doesn't reach your final destination. And then, of course, the internet isn't perfectly reliable, so your replies, like the reset, which you depend on in order to see what services are running or what ports are open, those could get lost, right? And then you might think that a port is open because the reset got lost, when really it's just closed, but the internet went out for a second. All these different kinds of issues. So, as well as that, this whole fingerprinting business, trying to identify what service or operating system is running based on patterns in its traffic, that's clearly an inexact science, right? You're looking at and comparing patterns. It's obviously possible for you to be wrong in that case. And so sometimes the fingerprinting will return completely inaccurate results or somewhat inaccurate results. This is easy to do on something like SSH or HTTP. You can actually write your own Java application that runs on those ports, and NMAP will often mistakenly still refer to them as HTTP or SSH. It's just the fingerprinting is so simplistic there that it just tends to default to, oh, okay, that's the port that's open, this must be what's running. As simple as that. And then there are various other issues that can cause you not to get perfectly accurate results. So remember, you might have to run the scan a couple of times, and that the results that you get are not necessarily gospel. They're just a starting point for you to look at. And now a warning about NMAP, even though you've already sort of gotten into using it, remember that we as a university share an IP range, and if you aggressively scan somebody, it kind of looks like an attack from their end, especially if they're getting a bunch of SYN packets that don't confirm their acknowledgments. That looks like a SYN flood on the receiver's end. So try not to scan too much. Don't scan like -A, -T4 on a service on the open internet or something that could get the whole network blocked. This is also a way to troll internal networks or people that you don't like. You get into their network by simply plugging something in or connecting to their Wi-Fi or whatever, and then if you want to get them blocked from the global internet or censored by their internet service provider, you basically just start scanning randomly out on the internet, and their legitimate users inside the network will get blocked because outside websites will think that they're being attacked. So you can, for example, connect to the, let's say you really hate your local neighborhood McDonald's. If you connected to the McDonald's Wi-Fi and then you aggressively started NMApping to Twitter or something, Twitter would identify as that as an attack from the local McDonald's Wi-Fi and basically block all the legitimate users of the McDonald's Wi-Fi from utilizing Twitter. Sometimes the implications are more far-reaching than that because the same service provider hosts many different websites. So, for example, Cloudflare hosts tons of different websites. So they might host, I don't know that they host Twitter, but they might host Twitter, and then they might host something else like Facebook. So as you bombard Twitter with your traffic, you also get the the whole network blocked from Facebook because they're hosted by the same platform. You could also end up getting the internet service provider to kind of block the whole IP for a while, thinking like, oh, well, this is obviously a compromised address. Look, it's sending all this garbage traffic. It must be compromised by malware, so we're just going to block them for a bit. And then, of course, they can't use the internet at all. So these are ways that people occasionally troll networks that they don't like. You can obviously connect some sort of device and do this periodically, automatically. It looks like an outage in that case, and it's very difficult to diagnose that that's the reason your network is failing, because somebody is trolling you by basically attacking websites from your network. But aggressive scans, again, are basically a lightweight DDoS and can straight up crash weaker machines. If you do a -A scan on something like a smart toaster, you might straight up break it just because its hardware isn't configured to hold that many connections at the same time or deal with that many connections at the same time. Let's see if my NMAP results ever returned. They did. So I was not able to get any of those open ports because, remember, -SS doesn't work on my own machine on localhost. But it was able to report less specific data about my machine than our volunteer got scanning me from afar. Mine's able to tell me that I'm one of these systems. I'm either Windows 10, Server 2012, 7, 8.1, or 2008. So basically, whatever non-response that it got was able to communicate to it that it's one of those operating systems. It wasn't able to match a more specific one. Let's try a connection scan instead and see if I get a different result. And we'll come back to this later again. Alright, so that's it for our review of NMAP, I believe. Oh, now we got a little more. So after you've uncovered the open ports and the open services, right, what do you do with those? Okay, so sometimes there's this little extra step beyond the scanning process, which is the automated vulnerability scanning. So once you know what ports are open and what services are running on them, you can actually, in some cases, automatically attempt to exploit those and break into the network. There are packages available to do this. They basically rely on services that haven't been updated and known vulnerabilities in those older versions. Nessus and Metasploit are two popular choices. Metasploit is free to try. Nessus is quite expensive. We probably won't use those here because I don't want you to have to install them on your networks, and the VMs likely can't handle them, so that's probably not going to happen in this class. But in some cases, there are tools where NMAP is built in as just one of the different tools in the package, and then the rest of the package contains ways to automatically exploit those open ports and services that you find available. It's just very cool, but also as long as the system administrators have kept the network updated and everything, these typically fail. These typically only find old vulnerabilities. Usually the cutting edge stuff doesn't make it into these kinds of tools, although I'm sure there are even more expensive tools that you can buy that sort of stay on the cutting edge of these vulnerabilities. Alright, that is going to be it for our automated vulnerability scanning. So with the election coming up on Tuesday, normally I hate current events, but I'm going to do a little bit of discussion on some of the cool cybersecurity issues that have popped up in this election. It's interesting because we were expecting, I think, as a nation to see hacking take a lot more of a role in the 2020 election. It was definitely pretty central to the 2016 election, and for all we know, it's still going to be a fairly big issue in this one. I think that it probably will, actually. We're probably going to see some sort of hacking allegations after the fact and those kinds of things. But let's talk about the major hacks that we've seen to date so far, or the major, I don't want to say that they're hacks necessarily, but cybersecurity events that we've seen so far and what we can learn from them in this election year. Okay, and as a disclaimer, these stories are all pretty new, and it is very likely that we will never know the full truth behind these stories. If we do ever discover the full truth behind these stories, it's very likely that I'm wrong. This is just my professional opinion based on the facts we have now, which comes with a lot of conjecture and is almost certainly going to be inaccurate. The truth is rarely as simple as we would like it to be, and so I just want to point out that I know that if the truth is ever revealed, that I will probably be incorrect here, just because I think that this is the most likely way these stories sort of played out. It doesn't mean that I'm correct, so don't take my opinion as gospel or anything, and really, these stories will probably never be heard from again after the election, so we'll likely just never know the truth behind them, because that's generally the way of election news, right? It sort of vanishes the day after the election is over, never to be heard from again. All right, so the first story I think that made national headlines and involved some sort of alleged hacking was the New York Times story about the Trump tax returns. So as many of you know, Trump has not publicly released his tax returns for recent years, so for the 90s and beyond. But in late September, so around the 27th, the New York Times published details of certain Trump tax returns. So basically for the years 2017 and earlier, they claim to have gotten information about his tax returns. They claim to have gotten the entire tax return for all of those different years, and they published a very large amount of details from those. But they didn't publish the returns themselves. They didn't publish the source material. And this is a little bit unusual. Many ask, well, why didn't they publish the full tax returns? Why don't they just release the entire document if they've got it? I mean, surely all of the information is there, right? So we contrast this with a couple of other events that were very similar recently. So in the 2016 election, the New York Times obtained a copy of a 1995 tax return for Donald Trump and published that. And they obtained this, they actually stated how they obtained it. They obtained it by mail. It was mailed to them semi-anonymously with the Trump Organization printed as the return address. Now, 1995 to 2016, do the math there, that is over 20 years, right? So the person who filled out that report may very well be dead. It was so long ago. And so the reason that these were probably disclosed, later we saw disclosures of ones from even earlier in the 90s. The reason that these were probably disclosed in their entirety is because that they were, even in 2016, so old at the time that nobody could reasonably get in trouble for leaking them. They're too old for anybody to care. And these were not particularly interesting to people in 2016, right? Because it had been over 20 years, so again, it's not something that you would see any kind of investigation over. Obviously, some people will claim to be angry about the leak or whatever, but it's hard to be angry over the leak of a 20-year-old document. So these are the full, we see the full original tax returns with the signature and everything, which I'll show on the next slide here. And the 1995 return also probably has some political motivation behind its leaking because it reports a very large loss. Then in 2017, another reporter, David Johnson, who I think was with the New York Times, but then he went to MSNBC with his actual evidence and ended up broadcasting it on the Madhouse show, I believe. But anyway, he receives a copy of a 2005 return just mailed to his house anonymously. So he is writing a book on the Trump campaign or Trump in general or something or another, it doesn't really matter, and he gets an anonymous copy of one of these returns in the mail. Now this one is stamped client copy, which means it's not a complete version as the IRS might receive it. This might be a copy like you get from your accountants before they submit it to the IRS. So let's look at what both of these look like. So in the 1995 one, you see sort of the complete signature, Donald Trump's classic weird swoosh thing, and then his two accountants and all of the other different preparer signatures. This report shows a loss of 915 million or something. It's a very big loss, so that's probably the political reason that they chose this particular one to mail anonymously. And then the 2005 return, we see that there is no signature. We instead see that stamp of client copy. This is probably not the one that goes to the Internal Revenue Service. We see the firm's name being blanked out on this one, so a little bit more sort of care taken to the privacy on this one, but it's still released in its entirety. All the pages are released from this one. And this one, again, probably released for politically motivated reasons, because this one shows $38 million in taxes paid, which is obviously a lot of money. So we have those two kind of contrasting narratives coming out. So why is the source missing in the 2021 other than the usual political reasons? Of course, we can think of many political reasons why the source might have been omitted in 2020. It's the material simply doesn't say what they want it to say. There's information that they don't want in there, etc., blah, blah, blah. There are many political reasons, but why, from a technological standpoint, might the source not be released in these 2020 leaks? So the first reason that the source material of the tax returns this time around might have stayed private is to avoid something called fictitious entry. And this is a concept that is more likely to be applied in returns since Trump took office, because he obviously is afraid of them being leaked. So in particular for the 2016 and 2017 report, there might be many cases of fictitious entry. And what fictitious entry is that when you distribute different versions of your document to different people, so you'll give one to your accountant, one to the IRS, one to whatever, every time you give somebody a different version, you make a very small mistake somewhere in the document. So you place a deliberately incorrect entry somewhere in the document. And that way, if the document ever leaks, you can confirm who it was that leaked it. So if you give Steve a version that says $2,300,997.98, and then you give Susie a version that says $2,998.73, well, the IRS doesn't care. That doesn't really change the material of the amount of taxes paid. They don't really look at the dollar column on people who are making millions, right? So it doesn't really matter from their perspective. But if you get that version, if the version leaks in the press and it's the version that says 73 cents on it, you know that that was Susie that leaked it, right? Because she's the only one that got the copy with the 73-cent version on it. And this is a very old tactic. It predates digital copyright. It probably predates computing, and probably predates even copyright law itself. You could do this without even having a law to uphold your original. You would simply enforce it by force or whatever. Once you discover who it is that leaked, you can just beat them up or whatever you would do before copyright law existed. But it's a concept that's best known from cartography. So especially in the early days of map making, before Google Maps and everything were popular, the map making industry was huge. Maps were worth a lot of money. And the biggest overhead in the map making industry is obviously the generation of the map itself, which required you to pay a cartographer to drive around and figure out where everything is and how to draw it correctly. It's a big investment to generate a map from nothing, a huge investment. Whereas if you were a competitor, all you had to really do was look at your competitors' maps and just copy it, and you could release your own much cheaper map since you didn't have any of that overhead. And so what map makers would often do to avoid being copied by competitors is that they would place fake cities, roads, etc. on their maps. And if somebody copied their map and it had that same fake road or fake city, they would be prosecuted very quickly. So there were a lot of cases in like the 70s, 80s, 90s of map makers suing each other because they discovered a fake road or a fake city on a competitor's map, which makes it obvious that they copied that map completely. The same tactic, again, often used on corporate and financial type statements, especially among wealthy people, to distribute versions of their documents with slightly modified values in order that they can determine who it is that leaked that document in the event that it comes out. So this makes it impossible for the New York Times to release the original. Now, you might say, well, why don't they just modify all of the numbers slightly, okay? And that way, those fictitious entries probably won't appear. They could just modify all the numbers by 10%, for example, and just say that they've done that. Well, unfortunately, most people probably wouldn't have kind of the mental bandwidth in order to sort of understand the concept of fictitious entry, and at that point it would lose them a lot of credibility if the real ones came out and all the numbers were different. The whole, oh, we just made fictitious entries in order to sort of not reveal our source probably wouldn't fly. Most people would just be upset that the entries weren't 100% accurate. So since people probably aren't too understanding about this kind of practice, it would be unlikely that they'd be willing to employ it. So they're kind of trapped in the situation of not being able to release the exact values. Another problem might be coded anti-copy measures. So you notice in both of the previous leaks, they uploaded the originals. They uploaded scanned copies of the paper documents. And this would be the expectation this time around. Anything else would ultimately be accused as a fake or something along those lines, and there would be some pretty legitimate criticism to be made there if the documents weren't uploaded in their original sourced version. So if they are uploaded in their original source version, then you run into what's called coded anti-copy. And this is used frequently by the film industry to distribute their for awards consideration copies, which I'm sure many of you steal on the Pirate Bay and other platforms, right? You'll always see at the beginning, for award consideration only. So the film industry obviously doesn't like that very much, the fact that sometimes their films reach the piracy websites before they even come out in theaters thanks to those copies. And so they've adopted this mechanism, this coded anti-copy mechanism. And all this is a very, very subtle pattern. The typical implementation in the film industry is a series of dots, like you see in the top right corner there. It's a very, very subtle pattern, and they apply it only to a tiny amount of the total frames of the film. So they might apply it to frame the 1,345,992 only, and only in the copy that they send to Steve. And then in the copy that they send to Susie, they apply it to frame 765,947. Right? And now if you see that particular pattern in a pirated copy on that exact frame, then you know that Susie leaked it, and it's time to prosecute her for doing so. And that did somewhat reduce the amount of these copies, but they're still pretty ubiquitous on the internet, as anyone who pirates knows, so obviously this doesn't work too well. But again, it can be used to identify a scanned document, so a very, very subtle pattern, maybe a couple pixels off on a single letter or something like that can determine whether or not the document came from Steve or Susie or Bob or whoever. So this kind of coded anti-copy can work on paper documents too. So the source material in this case was likely obtained by someone who probably shouldn't have disclosed it. So it could be a rogue IRS agent, someone who's still a current employee of the Trump organization. It could be an intermediary, like a delivery person, and this person could probably be subject to either legal or civil penalties, or just penalties to their reputation from being known as the person who leaked it. Particularly if you work in any of those positions, they all require that you have a certain degree of trust. If you're known as the kind of person who leaks information to newspapers, you lose some of that trust, and then it's difficult to continue to be employed in any of those industries. Now, the New York Times, as a media organization, is likely free from any kind of liability. If they publish the full content, they would probably be totally not prosecutable, but they still have to protect their source, which is likely why they haven't done so. All right, we'll contrast this with the next story, or I guess it's a pretty similar story, the Hunter Biden documentation that surfaced something like a week ago, right? So the story is an interesting one. Hunter Biden allegedly drops off his laptop at a Delaware computer repair shop and then forgets about it. The allowed period that you can come and pick your stuff back up again expires, and so the shop owner decides that he's going to go ahead and look at the computer, starts reading some emails, finds out that it's full of good, fun information, and immediately hands it over to the FBI, also gives some information to the Rudy Giuliani organization through an intermediary. Ultimately, New York Post breaks this story. And there are a lot of other interesting features of the story, like the store owner has an eye condition, and he can't say whether or not the person who dropped it off was Hunter or not. It's a very interesting story. So what's up with this, other than the usual political nonsense? Well, immediately after the story breaks, you see a lot of social media companies claiming that the documents come from hacked materials, right? And so they start to block both the story and, in some cases, the entirety of the New York Post from their website. The New York Post, ironically, about 20 times older than any of these social media companies, founded by Alexander Hamilton himself. So kind of an interesting new media versus old media fight, too. Later, social media yields and decides to allow the content and the article and stuff, but still kind of begrudgingly. So it's an interesting debate on that front, too. Now, what a lot of people allege here is that these documents were obtained by a process called parallel construction. And this is usually used to describe law enforcement practices, and it's a very derogatory term when it's used in that context. So, in parallel construction, you have one investigation or one source of the material that's dirty, so it's not constitutionally clean, and then you have the other one that's clean. And that's how they claim to have gotten the evidence in court when they really have gotten it in these sort of illegal mechanism. And so this might be the case here as well. It's a common accusation in hacking cases because the Fourth Amendment gives you very broad protections from authority in general in cybersecurity situations. So it's very difficult to prosecute hackers without having a clean source of how they managed to get, for example, the physical location of these servers. There are very few legal avenues available to pursue those. So you'll see this accusation happen a lot in high-profile hacking cases. The other thing that it could be are just glowy tactics. Glowies, of course, are federal agents or any kind of intelligence agent. Now, these folks can't leak documents directly, so if they were going to leak documents, this is probably how they would do it. They would pretend that they dropped it off at some repair shop. And which agency did this? Well, it doesn't really matter. It could be any of them. All right. So is either document genuine? It's impossible to tell. It's impossible to tell because the New York Times can't and won't release the original returns because it could compromise their source. And then the New York Post and the FBI can't and won't provide the laptop for fairly obvious reasons. It would compromise their investigation, all that good stuff. And so really the moral of the story is don't read the news because it's just a bunch of speculative nonsense anyway. So that's the conclusion I have. But still, all interesting stories all around. All right, that's it for today. Next time we will pick up on more cybersecurity content, and there will be another homework starting on Wednesday, so you've got the time off until then. All right, see you next time.